What is lambda expression? Lambda expression introduces the concept of functional programming in Java. Since Java is a pure object oriented language, function cannot exist independently. Functions have to be called through either a class, static functions, or an instance object, member, non static functions. In functional programming languages like JavaScript, it is possible for functions to exist independently and can be called from anywhere in the code. Okay, let's see this JavaScript program. This program is for adding numbers from 1 to n. And here is the function for adding the numbers from 1 to n. And we can see we are assigning the function to variable sum of n. And this variable is used to invoke the function here. So we can see dealing with function is very easy in JavaScript. Okay, we will run this program using JJS tool and we will see the result. So we can see sum of first 5 is 15. Okay, we will see how the same thing is done in Java program. So here we have interface sum of n. It has single method sum which takes a number as parameter and returns an integer value. Okay, let's see this Java file. Okay, this program is for adding numbers from 1 to n through implementation class and anonymous class. So here we have class sum of n demo, and here we have private static class loop sum of n which implements sum of an interface. This one. And here we are overriding the method sum which takes a number as parameter and returns sum of 1 to n. Okay, let's go to main. So here we are finding sum of n through an implementation class. Here we are creating instance of loop sum of n and assigning it to variable sum of n loop. And here we are calling the method sum of n loop. So this is the way we can have the same thing through implementation class. Okay. And here we are finding sum of n through an anonymous class. So in this case, an anonymous implementation of sum of n is created and assigned to sum of n formula. And here we are overriding the method sum, which returns sum of 1 to n. And here we are calling the method sum of n formula. Okay, we will compile and run this program and we will see the result. Okay, we have compiled this program and now we will run this program. So we can see sum of first 5 is 15. This one. And sum of first 10 is 55. this one. So we can see even we require a simple functionality to calculate sum of first n numbers. Both approaches require a lot of additional code in creating class and object and then calling the required method through the object. This is where lambda expressions are very useful. Functional interface. Before moving to lambda expressions, first let us understand the concept of functional interface. In Java, a functional interface is an interface with only one abstract method. Okay, let's see the functional interface. So this is the functional interface, sum of n. It has only one abstract method, sum. Okay, let's go back. The purpose of a functional interface is to provide a single functionality as defined by the abstract method. Lambda expressions can be used to provide the implementation of function declared in such interfaces without the need to create class. Functional interface annotation can be added to an interface which needs to be compliant with functional interface definition. Although this annotation is not necessary to declare a functional interface, it is good practice to use it to prevent violation of the functional interface design. Even if an interface has methods with default implementation but only abstract method, even then the interface is considered as a functional interface. Okay, let's see the functional interface. So we can see we can add the annotation functional interface here. Okay, let's go back. Java 8 has introduced a lot of functional interfaces. It is available in java.util.function package. Okay, let's see the documentation. This is the documentation of already available functional interfaces. We have by consumer represents an operation that accepts two input arguments and returns no result. By function represents a function that accepts two arguments and produces a result. Similarly, we have consumer represents an operation that accepts a single input argument and returns no result. And here we can see we have other functional interfaces. We have function represents a function that accepts one argument and produces a result. And here we can see other. We have predicate here represents a predicate boolean valued function of one argument. We have supplier here represents a supplier of results, and we can see the details here. So we can see we have lot of functional interfaces already available in Java 8. Syntax of lambda expression. This is the syntax of lambda expression. Parameters, arrow operator, expression or block of statements. On the left side of arrow operator, we can have single parameter, multiple parameter or no parameter. And on the right side, we can have expression or block of statements. Lambda expression creation and invocation. Here are the steps. Step 1. Declare the interface with one abstract method. So here we have interface expr interface. It has one abstract method evaluate with one parameter of type int and return type is int. Step 2. Create the lambda expression and assign it to interface variable. So here we have created a small lambda expression x arrow operator x into x and assigned it to interface variable expr. Here x is parameter and x into x is expression. Compiler will know the type of parameter and return type by context. Step 3. Use the interface variable and method to invoke lambda expression. So here we are using expr and method evaluate to invoke the lambda expression. Creating lambda expressions. Okay, let's see the different ways for creating lambda expression. X arrow operator x into x. Here x is the parameter and x into x is expression. The type of parameter and return type is known to compiler by context. Let's see the next one. Here x is parameter and we have block of statement returning value. So here parameter is inside parenthesis and we have specified the type of parameter. And in expression we are checking x is greater than 1000 and x is smaller or equal to 1000. So here we have two parameters in parenthesis and their type is specified and block of statement returns value. Here we have empty parenthesis, that means we don't have any parameters, and in block of statement we are just displaying a string. So this is the functional interface sum of n. It has method sum which takes a number as parameter and returns an integer value. Okay, let's see lambda expression demo1.java. This program is for adding numbers from 1 to n using lambda expression. Okay, let's go to main. So here sum of n interface is implemented through lambda expression. This is the lambda expression. N arrow operator block of statements. Here lambda expression is assigned to variable sum of n impl of interface sum of n. And here we are calling the method sum of n impl. We are passing the parameter value 100. So it will come here and it will execute this block of statement. Here value of n is 100. Okay, we will compile and run this program and we will see the result. So we have compiled the program. Now we will run this program. So we can see sum of first 100 is 5050. So this block of statement is executed and it returns the value of this expression. And here it display sum of 1 to 100. Okay, let's see this program. This program is for adding numbers from 1 to n using lambda expression and functional interfaces. So here we are importing function dot predicate, by function, long function, supplier. Okay, let's go to main. By function. By function is a functional interface that takes two arguments of same type and applies the given function on them and returns the result of same type. So here we have lambda expression. It has two parameters of type string and this is the block of a statement returns string, and this is the functional interface. And here we are calling the method apply of space concat, which is of type functional interface by function. Okay, let's see the next one. Predicate. Predicate is a functional interface that takes a single parameter and returns a boolean after evaluating test. So this is the lambda expression. We have number, and this is block of a statement returns boolean value. And this one is functional interface. Variable is even. And here we are calling the method test of is even. And parameter is value 10. So it will return true because 10 is even value. And here we are calling the method test of is even, and we are passing the parameter value 11. So it will return false because 11 is odd. Okay, let's see the next one. Supplier. Supplier does not take any parameter. So this is the lambda expression. So we can see there is no parameter. Empty parenthesis is used. And this is block of statement. It returns string. And here we are calling the method get of OS name. So the returned value, string value will be displayed here. Okay, we'll compile and run this program. So we have compiled this program. Now we will run this program. So this is the result. Concatenation, hello world. The return value from this block of statement is displayed here. Hello space world. Check 10 is even, true. So this is returning true because parameter value 10 is even. And this returns false because 11 is odd. And here this returns name of OS, which is Windows 8.1. It is displayed here. So we can see in this way we can use already available functional interfaces for lambda expression. Lambda expressions in streaming APIs. Java 8 introduces the streaming APIs to efficiently process aggregate data sources like collections, arrays, and IO resources. Aggregate data source means a data source which holds sequence of elements of similar type. For example, a list of students, an array of numbers, or a text file. Using streaming APIs, we can use aggregate operations of functional programming like filter, map, reduce, and so on to process the aggregate data source. This will greatly reduce the complexity of code. Streaming APIs internally divides the query into smaller subsets to make use of multiple processors efficiently, and the developer need not worry about parallel programming. Lambda expressions are used in streaming APIs to provide the functions for aggregate operations. Okay, let's see how it is implemented in Java source. Okay, let's see this program. This program is to display time zones using streaming APIs and Lambda expression. So here we are importing time zone, stream. Let's go to main. So here we are getting all the time zones in string array time zones. And this is the first approach, involves the old way of looping and filtering through an array using if. So here we are iterating string array time zone, and we are checking if it contains Europe, then display it. So here we are displaying time zones which contains Europe. Okay. So here we are using the streaming APIs to first filter the entries and then print the filtered entries. And here we are going to display US time zones. So here we are using stream, stream of time zones. Then we are using filter, and this is the lambda expression. TZ contains US. So first we are filtering US, and then we are using for each TZ arrow operator and this statement for displaying the filtered entries. So we can see this is very simple comparison to this old way. Okay, we will compile and run this program and we will see the result. So we have compiled this program. Now we will run this program. Okay. So we can see Europe time zones. So here we are displaying Europe time zones in this way. Now US time zones. So we are displaying US time zones using streaming APIs and Lambda expression in this way.